This class is concerned with search engines, and it's one class amongst several on this topic. So it's worthwhile making sure that you've looked at the other classes in the series as well. So first of all, search engines. Well, how does it work? There's a user interface. It allows you to type a query and displays the results. So generally speaking, we access a search engine through the browser. So we open a browser such as Chrome or Internet Explorer, although Internet Explorer has been phased out, Firefox or whatever it is we're using, Opera or whatever. Anyway, we access the search engine through the browser and we type a query in there. So that's the interface. That's how we access the search engine and how also we get our results. It's a searcher. The search engine is a searcher. It searches the databases for matching queries. So it looks for keywords in what we've typed in, and then it looks to see if those keywords are available somewhere on the internet. A big job, but it searches out keywords and brings back the sites. It's also an evaluator. The engine assigns scores to the relevant information that it picks up. So it retrieves information and then it assigns a score to it. In other words, the information it picks up may be highly relevant in the context of the query, or it may not be. So it tries to bring back the most relevant. It's a gatherer. The search engine tries to gather information. So it, if you like, it sends out bots. It sends out queries within the internet to try and find information, and it gathers that information together to present to us, the people who initiated the query. And it indexes the information. It categorizes the data that's collected, and it tries to organize the data in a way that makes it easy for us to understand and to access. So we've picked up on 5 parts: the user interface, the searcher, evaluator, gatherer, and indexer. And these are attributes of the search engine. Now I want to talk about these in a little more detail. And we'll start with the user interface. Well, it provides a mechanism for the user to submit queries to the search engine. Without the user interface, we would find it difficult to access the search engine and to type in a query. So we need some interface. We need some link between us, the user, and the search engine. The interface is normally a web browser. So we could use forms, and the forms could be very user-friendly. A form is essentially a place where there is a box into which we type in a query. We type in a query, or we type in some words. And that's really what the search engine is. It presents us with a box. It's asking us, what do you want to know? What's your query? So it's a form, and we fill out the form. We enter our data into the search engine. We say we are interested in cars of a particular year, or we're interested in computers of a particular type, or whatever it is. And having filled out the form, having entered the information into the search engine will then pick up on our keywords and go and do the search. The user interface also displays the results of the search in a convenient way. It comes back in the search in the web browser. The web browser presents our queries, and it also ranks our queries. We'll talk about that later. It evaluates our queries and presents the best results at the top. And a summary of each match is also shown. So it's not just it gives us the match. It says this site has got the keywords that you typed in, but it also tells us a little about the site, so we can read a little about it to decide before we click on it whether we want to access that site or not. So it gives us a summary, a small amount of information about each of the sites that it's found and brought back to us following our query. Now the searcher part, well, it's a program that uses the search engine's database to locate matches for specific queries. The search engine's database means the search engine collects keywords. It indexes the keywords, and that enables it to quickly find where the keywords that you typed in your query exist. Now when I say you type in keywords in your query, you may type in a general question. How many computers were produced by Dell computers in 2012? That could be a query. Now there are lots of keywords in there. Computers is a keyword, Dell is a keyword, and then we're looking at how many. So the search engine will be picking up on the keywords and trying to match all of those up and bring back the results. Now, a database of a search engine holds extremely large index pages. You can imagine the database for a search engine being phenomenally large. It's trying to index almost the internet, and the internet is amazingly big. What it uses is what's known as an algorithm. An algorithm is a method, a mathematical method of finding a solution. And what search engines do is they go about looking for the information in a very structured, methodical form. They don't just randomly go looking for the information. They are very logical about trying to track down the information. So they use algorithms to try and solve the problem. They use, if you like, mathematical approaches to try and find the information that we're looking for. So it's a highly specialist type of search. And these searches, these algorithms, are the results of years of research by computer scientists and mathematicians and engineers, and they don't just happen. They're not easy things to develop. But once developed, it means that large amounts of information can be searched very quickly. And you can refer to many computer books in libraries and online to see in more detail what is involved in these algorithms. But generally speaking, they're just methods, very sophisticated methods, albeit, of finding information, addressing the query that the user has typed in, and bringing back the information that's been sought. Now it's also an evaluator. The searcher returns a set of URLs that match the query. The URL is the Universal Resource Locator. It's the address that you've typed in. Or if you type in a query, perhaps not an address, you type in a query, it'll bring back the URLs that match that query. So it'll bring back pages and sites that are related to your query. So if your query is how did we land on the moon? That's the query. How did we land on the moon? It's a very vague query, but nonetheless, then the URLs that come back will be addressing that issue. It'll talk about moon landings, and it'll talk about the Apollo program, and it'll talk about the lead up to it, and so on. And it'll bring back a whole set of URLs, a whole set of sites, all discussing related topics. Not all the hits will match the query. It's inevitable that some that will be brought back will not be very specific. Some may be brought back because the keywords have not been entered correctly by the webmaster. The webmaster entered keywords which were not correct. So sometimes hits come back that do not match the query, and we wonder, how did this happen? Well, it happened simply because there was an error at the time the website perhaps was developed, and the webmaster developing the website entered the wrong keywords, so that the search engine picked up the keywords that were entered for the site, but these keywords were wrong. And that's one of the main ways it can happen. The more references that a page gets, the higher the ranking the page will become. If a site has been hit a lot, if a lot of people are using it, then it'll become one of the principal sites that come back when a query is entered. So, for example, if I type in news into the search engine, the chances are I'll get back BBC, because a lot of people access the BBC, not just for news, but for entertainment and for different facilities that are offered by the BBC. So I just entered news, and I will get back the BBC, because the BBC is such a high ranking site. Now, how are the relevancy scores calculated? Well, generally speaking, they're calculated by the match, the correspondence that they've got to the query that was posed. Now, the relevancy scores vary from one engine to another. So Google will calculate the relevancy scores one way, and Yahoo will calculate them slightly differently. But generally speaking, the sites that come back should be relevant to the query. And the more relevant they are, the higher the score, the better they are. So it could be the number of times a word appears or a particular phrase appears. Now that may be a way in which the sites are ranked. The query words should appear in the title, perhaps. The title in the URL. That would be a good way of looking at the relevancy. If someone types in that they want to access CNN, they type in news on CNN, then there is a CNN site. So CNN will come up. That's a way, and that CNN will be relevant because it is the CNN site, so the relevancy will be very high. This meta tag, well, within the development of websites, there's a tag that's inserted for keywords, and this is what I've been saying earlier. If the keywords are entered by the webmaster into the site and they're appropriate keywords, then the search engines can pick up on those, and more relevant searches will be achieved. Now, number 4, the gatherer. It's a program that traverses the web and gathers information about web documents. Search engines are constantly on the lookout for new sites. What are the keywords for the new sites? It's constantly trying to bring those into its database, update its database, and it means that in future even more sites can be looked at. So when we pose a query in a search engine, many more sites could be brought in. But in order to do that, the search engine must be constantly on the lookout for new sites coming into existence, perhaps some sites going out, not being registered anymore. It's updating itself, and it's also updating the keywords associated with what's in its database. So the gatherer runs at short and regular intervals. So the gatherer is a facility that the web search engines send out. It's like bots that go out into the internet and search around and bring back information. They are querying sites all the time and adding to their database. So they bring back information, and the information is indexed, added to the database, so that in future when we type in a query, the answer comes up very fast because it's already stored in the database. So there are names for these little programs that go out looking for the information. They're referred to as bots, crawlers, robot, spider, and worm. And most people, I think, refer to them as bots. The little programs that go off looking for information and search around, bring back keywords, bring back some perhaps characteristics of the site, and it gets indexed and is stored on the database so that when we look for information in future, it's brought up very fast. Now the indexer, well, it organizes the data by creating a set of keys or an index. So it's pointless having a lot of data in the database and it's not organized. So the indices need to be rebuilt frequently. They need to be updated frequently. And it's important that the index reflects accurately what is out there, what is available on the internet. That users type in a query, it brings back the URLs, and if the URLs are out of date or if the URLs are not properly relevant to the query, it creates frustration. So we have, for example, in libraries, we have author, title, the international book number system. We have all sorts of information stored in libraries about books, about the types of books, large books, small books, children's books, and so on. So we have lots of information stored in libraries. And in a sense, that's what the index is doing. It's storing the keywords. It's storing a set of keywords that if a query types in those keywords, it links to that particular aspect of its database. But it could equally bring back some small amount of information about the site itself, which most search engines do. They tell us the address of the site, they give us the link for the site, but they also tell us a little bit about the site. Before we click on it, we get a feeling of whether it's what we're looking for or not. It's important that the returned URLs are not out of date. It's important that the index is kept up to date. So it's constantly re-indexing itself. It's constantly looking at what's in the index and bringing it all up to date. The index, the database and the indexer is extremely sophisticated and very large. So generally speaking, it's broken into components, into different search areas. But of course, there are links between them. So for example, if I type in cars, it'll take me to the component that stores information about cars. If I type in Ford cars, it will bring me to the section with cars and then look at the subsection Ford cars. and if I type in Ford Cars 2014, it'll bring me to a subset of Ford cars, and so on. So the indexer is very important in organizing the information, and this all enables searches to take place fast. So that when we, the user, open the search engine, type in our query, we normally type it in straightforward language. When we type in the query, we get a set of results coming back very fast, and the results are not just coming back to us, but they're organized and they're ranked in what appears to be a logical order, and with the top ranking sites appearing first. So that's an overview of how search engines work, and that concludes this particular talk. So let's leave it at that and say thank you for watching.